Okay, chemical reactions of phenols, Cole's reaction, synthesis of phenolic acids. Salt of phenol is treated with carbon dioxide under pressure to generate carboxylic acid group. Autoposition to hydroxyl group into aromatic ring. This reaction is known as Cole reaction. Sodium phenoxides treated with carbon dioxide and sodium salicylate, and then orthohydroxy benzoic acid, salicylic acid. Price rearrangement reaction. Aryl store is treated with Lewis acid in the presence of carbon disulfide to get ortho and para hydroxyl ketones. Is known as price rearrangement. Aryl stores treated with aluminum chloride in presence of carbon sulfide produces para-hydroxyphenyl acetate or hydroxyphenyl acetate. In case of mechanism, the lone pair of the oxygen of aryl ester attacks on Lewis acid and then produces an attack on the this carbon from the two ways, and one chance is the ortho position of the double bond, and another is the chances from the para position. So we get both in the ortho and para position. Reimer Tiemann reaction, phenol is heated with chloroform and aqueous sodium hydroxide to get orthohydroxybenzaldehyde, salicylaldehyde. Phenol is treated with chloroform in the presence of sodium hydroxide, produces orthohydroxybenzaldehyde, salicylaldehyde. Mechanism: the hydroxyl group abstracts the hydrogen of chloroform and produces the dichlorocarbon. The hydroxyl group abstracts the hydrogen of the phenol, and the negative charge of this oxygen phenoxide can move towards the ring, and the electron density of the benzene ring increases and attacks on this the carbon. Then after the chances, uh, again chance of this double bond electrons moves to this oxygen, and this electrons between the carbon and hydrogen neutralize the resonancy, and This product produces and comes in this carbon, the hydrogen, and removal of chloride. We get this product again. Removal of water produces this product. Ring substitution reaction of phenol. Phenol is the more reactive in benzene toward the electrophilic substitution because hydroxyl group activates the ring and orthopara position. And one example, the bromination of the phenol produces 2,4,6 tribromophenol. And nitration of phenol produces picric acid 2,4,6 trinitrophenol. When phenol is treated with consulfuric acid, it gives ortho and parasulfonic acid, position of the sulfonic acid of the phenol. Formation of aryl ethers, phenol is treated with the alkyl halide in the presence of base to the get aromatic ethers. When phenol is treated with alkyl halide in presence of sodium hydroxide, produces this product. In case of real example, the phenol is treated with chloroform, methyl bromo Caterman synthesis aromatic substrates such as the benzene, phenols, or aromatic esters. Ethers react with the hydrogen cyanide and gaseous hydrogen chloride in the presence of Lewis acid catalyst, typically aluminum chloride or zinc chloride, to produce the aromatic aldehyde. Formation of electrophile, the hydrogen cyanide reacts with the hydrochloric acid in the presence of Lewis acid, represented here as the metal chloride to formimidoyl chlorides complex. This generates the reactive electrophile. Electrophilic aromatic substitution, the electrophilic attacks the aromatic ring, for example, benzene, to form a resonance stabilized uranium ion, followed by the loss of the proton to restore aromaticity. This also an aldehyde hydrochloride salt. Hydrolysis, this at aldimine intermediate is treated with water, acidic wax to produce the final aldehyde in ammonium chloride. Benzene is treated with zinc cyanide and these other products. Chelation of compounds, phenols themselves have only one hydroxyl group. So simple phenols containing the group aldehyde in simple phenols does not chelate effectively. However, the substitute phenols with a benzene, however, substitute the phenols with another coordinating groups, aldehyde, carboxylic, nitro, etc., and the ortho position can deform the chelates. A metal salt to metal surface removes the phenolic protons, aromatic hydroxyl Polymerization of phenols, for example, polymerization of phenol is the formation of bakelite. Phenol is treated with the formaldehyde in presence of basic catalyst to form auto and para-hydroxyl benzene alcohol as intermediate. The solution containing these intermediates is treated in the acidic medium under pressure. Both linear and cross-linked polymers are formed with called phenol formaldehyde resin or bakelite. Phenol is treated with formaldehyde and autohydroxybenzyl alcohol, para-hydroxybenzyl alcohol, and then treated with water and produce the cross-linked polymer bakelite.